we're going to talk about Connect and the process of integrating Kafka and Cosmos DB. But I was thinking, I actually am perfectly willing to admit I don't know Azure Cosmos DB all that well, and I bet I'm not entirely alone in the audience. So tell us about that thing.
Yeah, so Cosmos DB is an exciting product, and before I joined this team, I was actually part of the product engineering team that took Cosmos DB live as a product, right? So,
Oh, nice.
um,
You know it fairly well.
yeah, so I know it pretty well. But we had back in the day, we had a number of internal Microsoft products or services or areas that came to the data team and said, "Hey, we're looking for a database that can do the following things," right? And we sat down and we looked and we were like, "Well,
there isn't one.
There isn't one." And we sat. Luckily, we've got an R&D team, and we threw it over the wall to the R&D team and said, "Can you help us?" And they came up with some really interesting things to solve some pretty awesome challenges. And that was the start of a service. All right. So Cosmos DB, it's a NoSQL database. It's designed from the ground up to be cloud. So we didn't take some box product and kind of cloudify it. It was built from the ground up to be multi-region distributed cloud database with super low latencies in terms of reads and writes. And I think we're still one of the only cloud service databases that provide an SLA on actual performance, right? So we'll give you an SLA that say, X percentile, I can't remember the numbers offhand, but X percentile of your reads will always be within 5 milliseconds, and X percent of your writes will always be within 2 milliseconds, or whatever those numbers are. And so we actually guarantee that at an SLA level, which is pretty unique, I think.
It is. It's always strange to hear about imposing extremely popular, ubiquitous cloud data service. There's no SLA on that.
Yeah.
What?
So, exactly. I mean, there's not only is there an uptime SLA, and I mean, uptime SLA is great, but there's actually a performance SLA, which we think is really cool.
It's typical, though.
Yeah, so. It was ridiculously difficult, and I think that's where it comes back to the engineering at the start. It was really engineered from the start to be that, right? It was designed to be this incredibly cool, responsive, low latency kind of service. And it's super easy to, it runs in every single Azure center that we have, because it's one of our Ring 0 services. And by Ring 0 service, we mean many other services rely on it. So it has to be there for other services to exist and operate. So it's in every single Azure region. Super easy to switch on multi-region reads, super easy to switch on multi-region writes. You just go to the portal or your CLI command in Bash or whatever you want and enable it through that. And within a couple of seconds, you have your database in multiple regions, and you can even write to multiple different regions, and it'll sort out conflicts and replications and stuff for you. So really, really super cool database. And one of the other cool things that we did with it is we started out as a core JSON database, right? So JSON documents, same as other ones.
I was going to ask, data model, API.
Data model.
Okay.
So we started out as a JSON NoSQL database. And then we thought, well, what are we doing under the covers in terms of how we're storing the data and how we're modeling it and how we're replicating it and how we're keeping the high availability and the uptime? It kind of makes sense to have other database models on the same platform, right? So we've actually added on top of Cosmos DB, so it's the same core engine, but we can now run a Gremlin graph database. So you can talk to Cosmos as Gremlin. You can talk to Cosmos with a Mongo API. You can talk to Cosmos with a Cassandra API. You can talk to Cosmos with a key value API. So there's a bunch of these. So in terms of the database, there's a bunch of APIs that now sit on top of the database, including our core JSON SQL API. But there's a bunch of these other APIs that sit on top of the core engine. So you get the same multi-region read-write capabilities now across multiple different kinds of models. And you don't have to go figure out the infrastructure under the covers for you. It's done for you. All you do is click a button and use it.
Right. And use the API of your choosing. Pretty cool.
Yeah, it's pretty good.
But there is an underlying representation of the data
Yeah.
that at some level you can peel some onion layers back and you can get to that.
Yeah, you can peel a
There's
couple of layers back, and I mean the data is all stored in a common data model, and
okay.
for the most part, if we're talking the core of Cosmos DB, it's stored as JSON documents that are
Gotcha. Okay, because that's how it started.
Yeah, that's how it started.
Good. Okay, because I'm sitting here thinking, hey, wow, we have 20 minutes left to talk. How are we going to talk about the connector? Because that sounds hard with all those models, but you don't. The connector, I'm assuming, picks one model. There's like one API to get to quote unquote real Cosmos data, and you go through that.
I mean, and the nice thing with this and the way the model, the multi-models work is that if you're using the Mongo API against Cosmos DB, right, we don't have to build a connector for that, because guess what? Mongo has built a Mongo database connector.
Fair enough.
So if you're using the Mongo API, use the Mongo connector, right? Use your Mongo SDKs, use your Mongo kind of drivers, use your Mongo tooling and your Mongo ecosystem. That's why we built it, right? So it bridges that kind of gap, and you don't have to then shift all your code away from your Mongo driver to a Cosmos DB specific driver. You can just use a different API, right? So the same with Cassandra. I mean, if you're using the Cassandra API on top of Cosmos DB and you want to pump data from Kafka into Cassandra, use the Cassandra connector, right? So we built the SQL core connector for our core API, right? And the reason we call it SQL, it's not because it represents a relational database system. It's not SQL Server, right? It's just the representation of the query language that you use to talk to your JSON documents, right? Because all SQL really is a structured query language. So select from some container where some condition is true, order by something, right? And we take that as typical SQL syntax, and we will then use it to kind of go and query our backend store. So, other JSON databases have a very specific, domain-specific language that you use when you kind of talk to them. We thought people are fairly comfortable with SQL, so why not give them a SQL way to talk to their JSON database?
Which is not how most of the JSON databases do it, but sounds downright pleasant.
Yeah. If you're familiar with SQL, it is certainly very pleasant. If you're not familiar with SQL, well, it's not that hard to learn.
Exactly. And you're soon going to be, if you're not familiar with SQL, then welcome.
Yeah, if you're
welcome to the profession. We're very glad you're here and you're about to learn.
That's it. I mean, if you're working with a database at some point in your life, you're probably going to come across SQL somewhere, right? In some flavor, whether it's Oracle or MySQL or Maria or Postgres or SQL Server, you're going to come across SQL at some point in your life.
Indeed, you are. Yeah. So, okay, that's cool. I actually did not know that about Cosmos DB, and there is a lot of cool stuff there. Let's get on to the connector. So you built a connector as a part of your customer engineering day-to-day. This sounds like precisely the kind of thing that would come up if the connector doesn't exist. Customer needs to get data into or out of Kafka or both.
Yeah.
Here you are. So
that's it. I mean, we were working with a customer, and the solution architects went in and spoke to the customer, and it was great. And the customer had a very long relationship with Kafka and loved Kafka, and did not want to move away from Kafka at all, right? But wanted to run in Azure. So
I like them already.
Yeah, they came to us and said, "Well, what do we do?" Right? Customers got these messages, has an entire ecosystem and tooling built around Kafka, and they absolutely want to keep that. But they've seen and loved Azure Cosmos DB. How do we build this integration in between them, right? And, we kind of looked at it and we went, well, you can write a bunch of custom code and you can have then a bunch of apps that are deployed and, Kafka readers and writers, and you can do all of that stuff yourself. And we spoke to the customer and they were like, yeah, we don't really want that. Our whole Kafka environment is managed, and we don't now want to have this unmanaged thing that we
not how you do it.
Yeah, we don't want to have to go and employ a bunch of developers to develop and maintain code and worry about versions, and they weren't interested. So they were like, we've got this cool thing already that we're using called Kafka Connect. We just want to keep using Kafka Connect because we use it, we love it, it's great, it's low touch for us, it sets up, it works, help us. So we looked and, well, there was no connector for Cosmos DB, right? No fault of anybody, but new database, not our normal wheelhouse. So we thought, okay, let's go take a look. And luckily, there's some good documentation by Confluent and online. You can go look, and there's a sample connector that gets you started. And we thought, this doesn't look too difficult.
It's not. You look at the API and you're like, oh, come on, I just bang this out in a day.
Well, that was my exact thought. I almost said it to the customer. I was like, yeah, don't worry. On a Friday, I almost said, look, by Monday, I'll have a connector for you. Because, you look at it and there's one interface with like 4 methods and another interface with like 4 methods. And I'm like, easy, right? I'm just going to go knock that out.
And just the concept. This is why the first play was, why don't we just write this? Who needs a connector?
Yeah, exactly.
It seems so simple.
Yeah, and that was the thing, right? So we first thought, well, we don't even need Kafka Connect and a connector. But then you start digging into the weeds and you think, oh, okay, hang on. It gets a little more difficult, right? You've got partitions and you've got checkpoints and you've got offsets and you've got restartability and you've got at least once or, guaranteed once delivery of messaging. You've got ordered messaging delivery. And it's like, oh, hang on. Okay, now it's starting to get a little bit complicated, right? And I didn't really want to go and rebuild a whole bunch of that stuff when there was already a platform that did most of it for us, right? So I thought, all right, cool, Kafka Connect. So again, foolishly, I thought, I'll knock it out in a weekend. Well, let's say it didn't take a weekend. It took a little bit longer. I had probably a working prototype in about a week that totally got them a message out of Kafka and stuck it into Cosmos and took a change out of Cosmos and stuck it into Kafka. And I thought, great. Proof of concept proved, it works. Customers saw it, they said, when can we have it? And that's where the journey with Kafka Connect started. And it's been quite a journey, but it's been a fun journey since.
So what got interesting after that first week? Because this is like always the data integration story. It's not just a Kafka Connect story. It's anytime you're connecting thing to other thing. It's usually conceptually simple. JSON documents, getting them into messages or messages into JSON. You're like, come on.
How difficult can it be?
You need to explain that.
Yeah. How difficult can it be? Well,
but the answer is difficult.
I mean, it's not. I don't think it's difficult. Conceptually, it's easy. And like I said, I got that first version of the connector out really quickly. But then you start finding those little nuances and those things that trip you up, right? And like one of them, for instance, was quite simple at the time, and we got stuck. And luckily, I found Kafka Connect already had other people stuck on that, and they've got a good solution for that. Is message formats. So you've got JSON. Well, that's great, but you also have JSON with schemas, without schemas. You have JSON as binary in the terms of Avro, and you have all these other kinds of formats. And it's like, well, okay, how do I deal with that, right? And if I'm writing a connector that can be used by anybody, and Kafka takes any of those kind of message types, I'm going to need to be able to deal with those message types. And I thought, oh, this is going to be a pain. But luckily, the way Kafka Connect is structured, and when you build these things, there's the connector, there's transforms, and there's converters, right? And so you can actually just go and pull one of the converters. If there's a converter for Avro or for JSON with schema or whatever it is, you can go pull one of those converters and use them. And if there isn't a converter that suits, then there is a model that you can actually go and build custom converters, right? So if you've got some funky format that you're using, and you can then just go build a custom converter and plug it into plug your connector into that. So the way Kafka Connect is kind of structured, that it makes it easy to have converters, transformers, connectors, makes your life as a developer so much easier, right? Because you can just go in and target the piece that you need.
Those are kind of the three chunks of architecture that probably matter. Yeah. And in that order, converter, transform, connector, transform, converter, thinking from an input, a source connector coming into Kafka.
Yeah.
in the reverse order for a sync connector. But yeah, those are the three pieces. And by the way, if we're just talking about Kafka Connect, like, everybody knows what Kafka Connect is, and gee, what's your problem? If you don't, there's a link in the show notes to an episode. We're going to try to include a link in the show notes to one or more episodes that are some good intros, or just other materials online. So we're not, if you're brand new and you don't know what Connect is, it's actually very normal for a human being to not know what Kafka Connect is until somebody tells you.
I don't know what Kafka Connect was. I'd worked with Kafka for many, many years, and I had no idea what Kafka Connect was.
Right, you can miss it. So
yeah,
follow the links. So we're intentionally
called Connect.
Yeah, we're intentionally not giving all the background on that, but there's links in the show notes for you to check out.
Robin Moffat as a spoiler.
And it's probably going to have Robin Moffat's name on it. That's probably all of them, basically. So
absolutely.
Yeah. So what? Give us an example of something that got interesting because you said you deploy it. Here's the basic thing, and then you discover, oh wait, it's difficult. What's the thing that?
Yeah. So the customer was running it for a while, and kind of came back to us and said, well, we're losing messages, or we're getting duplicate messages. And we were like, oh, that's not what I want to hear.
Right.
So we Kafka's got its awesome way of managing the checkpoint and watermarks and kind of knowing where you are in reading a Kafka topic, right? So, and Kafka Connect does a really good job with Kafka of managing those offsets and those kind of checkpoints, right? So when the connector restarts, it can say, hey, I was at this point when I failed, give me all the stuff from this point on, right?
Right.
And that's awesome. So that worked really, really well. But going the other way from Cosmos DB into Kafka, they started missing messages or they started getting duplicates, and we were like, oh, what's going on, right? So we dug into it a little bit more, and Cosmos DB's got this awesome concept called a change feed, right? And you can subscribe to the change feed. And as changes happen in the database, it pumps those changes into a change feed, right? So kind of like a change data capture, but it's an actual feed that you can subscribe to, and all the changes to a document just appear in order in that change feed, right? So you can grab.
Seems like one might want that if one were writing a source connector.
Absolutely. If that wasn't there, I wouldn't have even thought about writing a source connector, right? Because it would be really, really difficult to do that. I'd have to go and figure out what's changed since the last, and that I would have just built a sync connector. But luckily, there is that change feed. So I wired up the source connector on top of the change feed. Now, the change feed's also got its own way of managing checkpoints, right? So when you talk to the change feed, you're telling it, this is where you got to give me all the changes from this point forward, and you can set the checkpoint back, and you can set it forward, and all sorts of cool things. Turns out when you've got a system on the left that has checkpoints, and you have a system on the right that has checkpoints, it's probably a good idea to keep those checkpoints in sync with each other, right? Because if they aren't in sync with each other, all sorts of cool things can happen. And digging through those details, that's kind of what happened. We were getting those checkpoints out of sync with each other, and that's where we were getting skipped messages or duplicate messages. So it took a while to kind of get that right. And the concept of exactly once delivery when you're a distributed worker platform as well is really hard. So Cosmos DB being a distributed database, Kafka Connect having multiple workers and multiple workers trying to kind of read changes out of your database into a Kafka topic. That distributed nature and having exactly once kind of delivery gets quite tricky, right? This message I've delivered, and this worker says, oh, that message I'm delivering, oh, no, hang on, that worker's already delivered this message, don't go and deliver it again, kind of thing.
Right.
So those semantics of making sure that exactly once worked in a distributed manner, that became a little bit challenging, and that took us a considerable amount of time to engineer that, probably longer, or definitely longer than building the initial connector took. Was just figuring out how to get it to do exactly once in a distributed manner. So super hard to do.
Without, I don't know if there's time to dig into all of it, but was idempotency key to that? Making writes from the standpoint of the source connector, making writes idempotent? Is that the
Yeah,
magic?
I think we looked at that, and it's super difficult to do, but idempotency is definitely one of those. I guess the challenge was more when, let's say, um, the connector fails for some reason. Someone shut the Kafka Connect cluster off, or whatever the case, your connection broke, and you restart your connector up. It was really difficult to kind of know what had been written to Kafka already and what has changed in the database, and making sure that we were kind of in sync with each other, so we started at the same point. And that's where the challenge kind of got. Sometimes the connector would be ahead or behind where it thought it was in Kafka, and then it would start sending duplicate databases, or documents, or it would think it was further ahead, and it would start at a point further than Kafka, and then we were missing messages effectively, kind of thing. So
Gotcha.
it was more around that kind of resiliency of having distributed multiple workers starting and stopping independently of your database and your Kafka, and then being able to kind of resynchronize those things. So yeah, there was definitely an idempotency issue, but there was a little bit more as well. And there were some other challenges, when you're looking at a partition system like Kafka, and then you're looking at a partition system like Cosmos DB, because Cosmos DB is infinitely scalable horizontally, right? By just partitioning out the data. Same as Kafka, you can have thousands and thousands of partitions. You have the same thing in Cosmos DB. And now writing something that's efficiently kind of doing this multi-partition story and keeping things in order and in sync, that got a little challenging as well. Being able to say, all right, this worker, you're dedicated to that partition, or this worker, you're working with that partition, or you're working with a set of partitions. So there were some challenges so I guess the biggest challenge for us was at scale, and at a distributed nature, making the thing resilient and stable, right? It was really, really simple to get it out in a single topic with no partitioning and a small Cosmos DB environment. Getting messages flowing both directions, trivial. It was a weekend's worth of work. Getting it to do that at scale, reliably, without missing messages, that took a little bit more engineering.
Yep, that's it's always weeks harder than it seems.
It's
any development task, but it's always funny to me how deceptively simple integration code is. It's like date and time code. You should be able to knock this out right away, and some
yeah, I always say
unseemly number of hours later, you're
80% of the functionality takes 20% of the time, and 20% of the functionality takes 80% of the time.
Right. Definitely an odd sort of Pareto distribution thing happening.
Yeah, exactly. And then when you have someone saying, well, it took you a week to write the whole connector. Now it's taking you 6 weeks to kind of just do this one feature. What's going on?
Yes, yes, it is.
Let me explain that to you.
Yeah. Right. And this is out in the wild and available now. I mean, I know it's on Confluent Hub as an option, and so it's being used, I assume, by others.
Yeah, so it's being used by a good number of customers at the moment. I'd probably say 10 customers is a good guess, but they're large customers in production. You'll see if you go to the Confluent Hub and you look for the connector, it's there. You can grab it, you can use it. It's gold verified or gold certified. It says it's still in preview, which it is. And even though it says it's in preview, it's fully supported by Microsoft. We'll support it, we'll add features, we'll address issues.
Nice. Okay.
And it's also open source, so go to GitHub, search for Kafka Connect Cosmos DB, and you'll find it. And we can put a link in the show notes to the repo as well. So if you have any issues, just open issues on the repo. They come to my desk, and we triage them, and we'll deal with them. And of course, we've already had contributions from the community, so thanks for that. But it's fully open source, so if you see something and you want to contribute and you want to add features or you want to change something, feel free to go and submit a pull request, and it again lands on our desk, and we will review and merge as we need to. So we've already had, just yesterday, I think, someone from Confluent, wrote a validator, config validator. So now when you're actually entering in your configuration, it does real-time validation of the configuration. So you know whether your configuration's valid or not, which was a cool contribution. So thank you.
And maybe it logs descriptive error messages if it's not. I mean, I'm just hoping.
It does. It logs very nice descriptive error messages now. So yeah, and so that's a good thing about it is even though it's beta now, but we've handed it over to the Cosmos DB engineering team, so it's going to become a full supported official product from them. You'll be able to open support cases against Microsoft support if you need to. But it's also just we want to kind of keep it open and part of the community. So yeah, we love to see kind of contributions, and if you've got issues or feature requests or whatever, just go log them in GitHub, and we'll take them from there.
My guest today has been Ryan Crocour. Ryan, thanks so much for being a part of Streaming Audio.
Thank you very much, Tim, for having me on the show.